Thank you very much, Michael. Thank you very much for inviting us and also for have the opportunity to be here. So it has been a very exciting week and a lot of new friends and new contacts. So really, I enjoyed a lot, and I think that for us it was important to come. So I'm going just to speak a bit about multi-use offshore platforms, but from the perspective of our research infrastructure. So within the cluster, we play that role. And also I'm going to introduce a bit the collaboration process that has been around this, around the projects in relation with multi-use offshore infrastructures, and also the collaboration at the European level in order to achieve it. So you have here in the presentation several results of the one of the European projects in relation with that. But first, I would like to start from the beginning. So why this concept of multi-use offshore infrastructures and co-location, from where this concept came? So really, this concept appears trying to look for using in a much more intensive the space, the ocean space, and also trying to look for new innovative business model in order to make different activities much more efficient when they are combined together. So of course the driving force has been always the marine energy, especially in the North Sea. The offshore wind energy have already occupied a large amount of space, the ocean space, a lot of square kilometers going on, with almost now around 5,000 devices in the sea. So that is a lot. And and of course the separation between these offshore wind should be in the terms of kilometers. So why not use in a much more intensive this space? Why not putting together several activities, like, for example, offshore wind plus aquaculture, or why not also add other activities like marine ports? Why not going offshore with offshore ports or even leisure? Why not trying to combine these activities? So the idea was try to look in parallel to, of course, the offshore wind industry is trying to lower their cost and to be competitive. But in the meantime, why not use in parallel other approaches, other business model combining different activities? Of course, this combination could be done just in a single structure, that can have several uses, or either you can just co-locate in the same area different activities, sharing some maintenance operations or some basic infrastructures, and trying to make it much more profitable. So that was the approach. So with this approach, of course, we have to take into account that these industries, the offshore industry, offshore wind industry, the aquaculture, the transport, the leisure industry, normally they have their own problems and they have their own risk. They have also sometimes their own procedures for consenting authorization. So indeed, when we try to put that together, either in a single infrastructure or we try to co-locate these activities, also we have some new risk and some new uncertainties. So that's the problem. Normally, also in our experience, when we are trying to involve the industry, especially the maritime industry, they are very, very conservative. I mean, they are really not like to do all the changes in one single step. Sometimes it's difficult to have a completely new thing that have to be qualified, that has to be standardized, that have to be, at the end you have to go to the insurance and to see what happened with that. So we also have to take in mind that the combination of these several activities is a problem. Of course, the advantages is that by now you can improve the use of the space, the intensity of the use of space, and also you can, in the case of the offshore floating platforms, you can also go offshore and take profit of the large amount of resources that you can have there. So, of course, it's not only a question of infrastructure or the technology. I mean, to having the right technology to run these different activities together. It's also a question of legislation, environmental barriers, safety and security. So if each single activity have their own procedures, their own problems, when you combine several activities together, when you combine, for example, offshore wind with aquaculture, you have to take into account new risk, and also you have to deal with the administration. So that is another part of the problem. So we have a technological problem, we have a regulatory problem also that have to be addressed. So in 2011, the European Commission tried to focus this approach. So they allocate 14 million euros in order to support 3 projects, H2 Ocean, Mermaid, and Tropos, in order to look for that, how we can, what type of new concept we can develop for harnessing different resources in the offshore area. So, in the case of H2 Ocean, they were much more concentrated in the production of offshore wind and the conversion of this offshore wind into hydrogen, and also in the way that this hydrogen could be sent to the shore. I'm not going to be much more detail into this project because we don't have time, but also you have all the results in the web page of this project, and also in the European Commission. Anyway, if you are interested in any specific information or results inside of these projects, I can provide you detailed information. So all of these projects, they were looking first to the resources, the best places to do this combination of this combined application of the different activities. They also study the business model, the technology, and so on. But normally, they were just only at TRL 2 or 3. They didn't, only Tropos went until TRL 4, and a tank test was produced of one of the results in model 1-50, but the other ones were much lower TRL. Anyway, in these 3 projects, a lot of information was generated in terms of the problems associated, the new problems associated with the combination of these activities, also the consenting process, how that could be, also the social acceptance, many valuable information was produced in order to develop this new approach. In the case of Tropos, we were leading that one. We have developed solutions combining aquaculture, touristic activities, also wind and leisure for 3 different places, one in the Mediterranean, one in the Atlantic, and another one for the Taiwan that were also participating inside of the project. So with these, in these 3 areas, we study what will be the best resources, the best combination of different resources, and the best approach is to have platforms to combine these 3 resources together. So. As a result of these, these 3 projects involved most of them between 10 to 12 partners. So at the end of the game, almost 50 institutions were involved working on that. So as a result of that, the Commission decided, okay, I'd like to have an independent assessment of all the results produced by this project, and also whatever other solutions of combined activities, floating platforms for harnessing agriculture, other things, are in the market. So that was the Maribe project. This Maribe project was run during 2 years, and they have presented the results last summer. So what they have been gathering information about different combined activities, either using a single platform or just co-located activities. So they have at the end selected some like 15 different cases, and these different cases has been studied in much more detail by a panel of experts on different areas. Some experts were studying the business model, other ones related the problems related with the technical issues, or other ones related with the consenting and so on. So again, here you have a different, just a snapshot of the different combination that they have studied. Again, we are not going to be much more detail on that. All the whole information you can get it from Maribe project. Some of the information is confidential because they have been studying in very much detail with private information, the business case for each company. But okay, so you have that information there. So. Now, the European Commission has opened a new call that is going to start in February for going to TRL 5. And this in 2 or 3 years we can see what happened. Meantime, as we in Plucan, we are very much interested in these issues, so we have started to develop our own platform. So we have built it. We have built it also as a part of a co-location concept, in where we have a central hub, the platform, and around this hub we have several devices for harnessing wave energy, for for harnessing offshore wind, or for testing offshore wind devices, agriculture, and so on. So that is where we have the test site. This test site have 23 square kilometers, and we are located in the Canary Islands, just very nearby of the port of Las Palmas. So this is the central infrastructure. This is the platform is 30 by 30 by almost 40, so it's 8 meters over the water, and have a space of about 2,000 square meters, and will be deployed just in the last by the end of this month. So it's already it's ready now to be deployed. So with this platform we are trying to study much more in the concept of co-location, but with a central unit and the devices around. So thank you very much. Sorry about the time. Can provide much more detail if you like it. Thank you.
Thank you, Joaquin.
Thank you.
Hi, everybody. First of all, I would like to to ask you not to request any intelligent question to me today, because I am not the specialist of this domain. In fact, Patricia, you must have Patricia, which is my colleague, here to present this, but she has not the possibility to come. So I completely agree to what was presented by Joaquin, because not only we are involved in this program with him as a cluster, but this strategy has been made since 10 years by Polmer Méditerranée, and we are working on floating infrastructure and farms of windmill since the beginning of the creation of the cluster. So I will just present you some industrial project that's not cluster cooperation, but real realizations that have been founded or by the French government or directly by the European Commission, to have an overview of what we are doing in Polmer Méditerranée. There are some other projects that are made in the north of France, in Polmer, Bretagne. You know that there are two. You don't know, but I tell you there are two places where we are present as Polmer, in the north and in the south. And on this activity, it's quite different, because in the north, like in Ireland or in UK, the ground, the depth is very low. You have 100 meters on the continental plate for long time, and when you build something, you can simply put it on the ground. In the Mediterranean Sea, like in the Pacific, or we must build floating platform. So the two conceptions are completely different. That's why we separate, in fact, our activities. So you have here some example of floating support for windmill. These are projects that have been realized and funded. So the first one was Ideol project. It's a beton floating platform. In term, it's quite like what you present as your Proclan platform in Las Palmas. There are, in fact, three main companies in the south of France, including our American friend. And all provide this type of floating platform for windmill. So there are different conceptions. Each of it have its own performance interest. I will just underline that there are different types of windmill, and as you can see, the last one, Vertifloat, has an axis that is vertical. That's something that normally is better in terms of performance of production, because when you are in a place where there is lot of roll and pitch, if you have a normal windmill like that, you understand clearly that if there is lots of roll, the performance will be less each time you will have the movement of the axis. Instead, with the vertical axis, in any position, it is compensated, so there is a better performance of the turbines to the creation of energy. That's why we have lots of studies about this type of windmill. Also, what is very important for floating windmill is the way they will be anchored. If you need to have a 3,000 meters cable and lots of cable to anchor your windmill, you need to make a study that is very important to better to know exactly how you will it will react when the waves are very high. So there are lots of tools that have been developed, and for example in this project Stationis, this is a simulation tool that has been done in order to simulate and calculate the best liaison architecture that we can have in a park of windmill. So there are also other type of structures that we are doing. For example, this one, LIDAR, it's a buoy on which you have a LIDAR. It's something you understand to measure the wind. Some other project, this one could also interest you because it's a startup, a French startup that is creating this new generator, a piezoelectric generator. We believe this is something revolutionary, and the performance will be some already existing demonstrator show that it's very powerful. So we are looking for some investor for this small company to create a biggest infrastructure, a biggest generator to test it. What we also provide as project in the Polmer is all the equipment that you need, in fact, to connect your windmill, because when you have it, then you must deliver your energy on to the people. So the connectors are very important, and Power C, for example, was a project to create this type of connector to go deeper. And Babcock also is a member of our cluster. They are working on the stockage of energy. And to finish on a project, this is a project that my company has win at the European Commission. So my company is DCNS. You know that DCNS is making ships and submarines or aircraft carrier, for example, for France, and lots of ships everywhere. Sometimes we don't sell the ship to the Russian, for example. And as we have to diversificate our activities, the company has decided to invest in such activities of building big offshore platform. So this is something that has been presented and to the European Commission. The idea is to build this MOP for the port of Guyane. Guyane is in the north of South America. So in fact, there is a challenge in this zone. You have a water drought that is less than 7 meters. So if you want to use it and have big ships, big container, the only way to use is in fact to have a floating platform and to use it as a hub, and then having small ships that can make the transit to Guyana. So this project has been funded and now is under study. The idea is at the end, obviously, for the CNS to build this port. It's not only to make a study, but for the moment it's only the study. And to win it, in fact, it was necessary also to make not only a platform for shipping and a hub of container, but also to have the possibility of other activities. So the main activities that has been studied and that will be probably done on the platform is aquaculture. The idea is to keep, in fact, inside the platform the juvenile production, and having all the cage and all the production all around the airborne. Well, anyway, you will have a copy of this slide. There are some information about CapEx and everything. If you are very interested by this project, I can give you some more information. You can also contact Thomas Lockhart, who is the head of this project, and he will be very happy to explain you what he wants to do inside this project. This is really important to show you that there are now projects that are studied by a big company in order to build really the infrastructure. This is a new step inside for the future of this infrastructure. Thanks. That's finished.
Okay, my name is Neil Brown. I'm from a little firm called Float Incorporated, which lives here in San Diego. And I must admit that you're looking at 1/3 of the company right here. It used to be a lot bigger than it used to be, at least 3 times that big. On the other hand, nobody's ever quit the outfit. We've been around too long. One of our other major members, lives in Nice, France. He's expat American. Franklin Martin is his name. These gentlemen, I think, know him. He has been carrying on for quite a while in Europe. And do I click this thing to change? Is that the idea?
That's the big green button up top.
This one?
Yep, that's it.
MARIB. That stands for Marine Investment for the Blue Economy. It looks to me like the European version of TMA. Okay? Franklin was invited to attend some of these meetings at MARIB, and there he discovered a very interesting fact. MARIB was primarily interested in things like renewables. However, he learned that the Europeans are going nuts because they can't handle the new class of container ships that are coming down the line. 20,000 TEUs. The max they can handle is 10 or less. And as I say here, those seaports were built by the Romans. They can't jack them up to handle these, with the exception of perhaps Rotterdam. They figured that to improve their ports to be able to handle this new class of ships, which is coming, some of them are already there, it's going to cost them 300 billion euros. And Franklin said, wait a minute. We can give you an offshore floating port that'll handle the biggest damn ships you can imagine for about 5% of that. Oh? There you go. If you look at the fine print, the very bottom of that picture, you'll see that I did this slide 15 years ago. Imagine that. This was a security port, which we were pushing, which was supposed to prevent the entry of weapons of mass destruction into the continental US of A. We were going to have 5 of these, 2 in each coast and 1 in the Gulf. And all the transoceanic traffic was going to come in here, unload, have all of its cargo inspected by the latest and greatest, electromagnetic and computer-based inspection techniques without laying a hand on them, and transferred to coastwise shipping, which had the increased benefit of reducing the number of trucks on the road. These things were going to cost the order of $10 billion apiece. Here's a rendering of what one of those looks like a little bit closer up. This whole idea was taken over by Lawrence Livermore National Lab. Why? Because they do that weapons of mass destruction search stuff. That's their bag. And Hank Lauser is the fellow in charge of this thing, and he unfortunately isn't here. Michael will take you through his stuff. They've essentially taken this thing over. They do note on this picture that they drew down in the right-hand corner that they give a hat tip to float for the design. But that's kind of what it looks like. Of course, the artist didn't know that this thing was a breakwater, so that the sea state in the shipping end of it looks just as bad as the sea state in front of it, when in fact it'll be a flat calm. Okay, where are we going to put this thing? One of them off the southwest corner of Ireland. How's that? You'd say, well, why don't you put it in the English Channel, where all the traffic is? That's because that's where all the traffic is. There's a regular traffic jam there. You can't do that. So off the southwest corner of Ireland, everybody agrees, ideal location, and it would serve all of those routes that you see laid out in blue. There's a picture of the redesigned port. It's redesigned to be able to take these larger ships, and that's mainly in the length of the piers, which are here 800 meters, and in the space between them, so that you can get 3 of them, 1 on each side, plus the one going down the middle. This is bigger in overall dimensions, but not necessarily in area than what we had before. I can't read it from here. There's a number on there down in the lower left corner. It says wingspan. Can anybody tell me what the number is?
2676.
3676? 2676. So it's 2 2.2 kilometers for the wingspan. That tells you what the size of this thing is. It's got dockage, as you can see, of 7,200 meters, 7.2 kilometers. It occupies 335 acres, and an acre of this kind of structure is probably $15 million. So this is going to look like about, just for the structure, something under 10 billion, but then you got to outfit it, and there's a lot of outfit. Anyway, our European friends are very interested in this. Another thing that popped up was Saint-Tropez needs a heliport, floating one. This is a very quick concept design using hexagonal modules. Again, realize that all of these structures are built in reinforced concrete. There's no steel touching the water anywhere. Why reinforced concrete? One reason is it lasts for a very long time in seawater. Good example, on the west coast up in Canada, I can't remember exactly what port it is, there's a breakwater floating. That breakwater is a World War I merchant ship built in concrete. Still floating 100 years later. It looks like hell, but it's still floating. So reinforced concrete has got a lot of advantages, not the least of which is it can be built damn near anywhere that you've got a big enough dry dock or can make one. This is a part of this project, if you put it all together. This is a platform in plan view that's intended to go into Galway Bay in the north of Ireland. And you get a picture from this, not all the blocks are filled in. The basic structure is reinforced concrete plate, separated top and bottom by longitudinal and transverse bulkheads, and cylindrical tanks, which are in fact concrete, what do you call them, culvert pipe, which can be made very, very economically and very, very strong. Those are filled with air, open at the bottom. So what you have here, the basic idea of the pneumatically stabilized platform, is a smaller water plane area, sort of like a semi-submersible for drilling, that is much less sensitive in terms of motions and stresses to incoming waves. Does not respond. The purpose of this thing is for further testing, sort of on model scale. It's going to be equipped on the top edge, which is the windward edge, with wave energy converters, all 40 meters thereof. And we expect to be able to use university students for training, get learned up on all of this technology, and applying it ultimately for being able to run and otherwise maintain the offshore port. Okay, here's the wave energy converter that goes on there. How much? 2 minutes. 2 minutes more. Okay. It's a resonant device. It's known as the ρC, that is Greek rho times C, which stands for the impedance of ocean waves, mass density times speed of propagation. This is an impedance-matched device. In principle, it can accept all of the incident energy without reflection or passing any by because of its impedance match, and that works. The power is taken off in this case by linear electric generators, which in this case are made by Trident Energy. They're in the lower left corner. You see them, the vertical one. There's a vertical magnetic rod surrounded by a coil which goes up and down with the water level, cutting the lines of force and therefore generating electric voltage and current. These things already exist. Those magnets are 20 feet long and a foot in diameter, and they weigh 2 tons apiece. Another thing that's come up is the desire for offshore aquaculture. We suggested something that we had proposed earlier to NOAA, and did this with Hub SeaWorld at one point. And then this came up. Ireland wants to instrument the entire west coast of their island with wave energy converters. Well, guess what? We got one just for them. This puppy has got a wingspan of 1 kilometer. Okay? All the front edge is lined with these wave energy converters. And it also holds a dozen wind turbines. We proved long ago that the best way to go is to combine the two. Not just wind, not just wave, but wind and wave. OFOES stands for Offshore Floating Ocean Energy System. We have a patent on this. As a matter of fact, 2 years ago, we got an award for the best paper on renewable energy because we showed how to optimize the wave energy converter in terms of bucks per kilowatt hour or megawatt hour. And it says you don't want to go after the longest waves with all their energy because it costs too much to build the big damn capture mechanism. It turns out that the price goes as the fourth power of the wave period. So there's an optimum. And for normal waves, it looks like it's about 10, 11, 12 seconds for the maximum. That's it.
Great.
Because of all this, we're opening an office in Europe.
Thank you.
Thank you.
I want to thank Neil because he has been, first of all, very persistent. This is a guy, a small firm, as you can tell, that has been working for 15 years more on a project that is now coming to fruition. And the fact that we have the French, the Spanish, the European Union, the Irish, and to some extent the United States working on this, I think, is a testament that the time has finally come. So Hank Glauser is the principal investigator at Lawrence Livermore National Laboratories, and I'm going to quickly run through his slides. He could not be with us today. Hank has been here in the past. He's a terrific guy. He is, I would say, almost single-handedly been promoting within the U.S. government the idea of floating harbors in particular, and there's a lot of different kinds of things that will float. So I'm going to use his slides, and it really builds on a lot of the stuff that's been discussed, and in particular what Neil was talking about, because he actually adopted some of Neil's technology. I'm not going to read these because it's way too much information, but DHS finally is asking for information about this. Now, the reason they're interested is because of homeland security reasons, dirty bombs and all that kind of thing. If one's going to blow up, you don't want it in Long Beach, you want it out 20 miles offshore. So this is a very interesting, it builds exactly on what each of these guys is talking about, but Neil in particular has been working with Lawrence Livermore National Laboratory. So there is testimony going on for the first time about large floating harbors. This is the Portunus concept. It has a lot of advantages, improves detection capability. You can see that it's got a ring around the outside of the basic design that Neil talked about. There's been some, I'll call them enhancements, I wouldn't know, but that's at least the most modern idea that they would want, and it meets the requirements of State Port Act and various other things. Here are some different projects, and a couple of them were actually mentioned. The Guyana one was talked about by Stefan, but there is one off Dubai. They're talking about one right now at the north side of the Adriatic Sea. Venice is sinking, and yet the closest way into the middle of Europe is at the top of the Adriatic Sea. So there is a floating port conceived, and then on the Guyana, as Stefan talked about. So this is real stuff, and we're talking about billions and billions of dollars. So for all of our U.S. companies, our foreign partner companies, this isn't the day after tomorrow, but it is certainly not far away, finally. Here's a couple of big companies that are focused on this. Bechtel is a company that we've had here in the past speaking, and the Chinese actually had the temerity to suggest that they would build a port off of the east coast of the United States. Fortunately, the United States government hasn't taken him up on that, but President Trump, who knows. This is the Portunus concept, and Neil talked a little bit about this, the idea being two West Coast, two East Coast hub ports. This has tremendous advantages because you park it offshore, you don't have to do the dredging, and you revitalize all these small ports, and there's like 250 ports of some note, but probably only 10 that will be dredged to a deep enough to take these 20,000 TEU ships. So this is a very interesting model and concept. This is just a little bit about better movement of goods. It shows you that waterways are far more efficient than putting on a railroad or in a truck. This is just some of the market potential. These numbers are quite big. Capital is ready to go. The U.S. government doesn't have to invest in this, although my guess is they probably would have to do what they did after 9/11 when they did the Safety Act, which was to put government insurance on this, because how do you know the value of something that would be offshore? It may cost $15 billion to build, but who knows what would be on it at the time, God forbid, it were blown up. So the odds are that this would require government, not necessarily government funding, private sector funding, but government insurance. Number of agencies are beginning to show interest, but nobody has taken a leadership position. For those of you that go to Washington, please go talk to people. Tell them that floating infrastructure is the future, and it's something that we should be working on. Some congressional hearings that took place July 2016. Our very own Duncan Hunter, Republican, who is the House Subcommittee Chair on Maritime Transportation and Coast Guard, about 2 years ago, he spent a whole day with us. We had like 17 or 18 companies present to him, and he's a BlueTech file now, so it's great to have somebody like him that is really a supporter of both this concept and BlueTech in general. So what's needed? Legislation, direction from the executive branch, interagency coordination, of course, private sector involvement, and then some things from DHS. Again, you can have these slides. These have all been cleared. So if you could just play this short video, please. This is only about 1.5 minutes, I think.
We were an order of magnitude, literally a factor of 10 cheaper than we were expecting to, than we guessed we would be when we started the project. It was actually very encouraging, whether these numbers or the pre-adjusted numbers that were on the order of between $100 and maybe $400 per container. Given the value of what's in the containers, we did not see that as onerous.
Thanks, Donnie. So the reason that's important is that Lawrence Livermore National Lab put out a call, and like 23 U.S. universities, business schools from around the United States responded. They chose 4 of them to do a study. They went out and talked to the Maersks of the world, Hapag-Lloyds, and got a whole bunch of information to do an economic analysis. And you just heard what he said. This was I can't remember, he was Duke or one of the universities, and they were just amazed that they was not more expensive than they found, and they found the private sector was quite willing to work with us, because what's happening today is you're getting bigger and bigger ships coming in to a fewer and fewer number of ports, and it's creating it comes in, you have to move the cargo sometimes several times, and so the idea to bring it into an offshore port and then transship it to the right port really is very attractive. So this is something that is happening. You can see that from what's going on with France and Spain and Ireland. I mean, there's money going into this now, really billions, hundreds of millions, and now eventually billions of dollars and euros, and the Chinese are also working on this quite aggressively. I mentioned this a couple of weeks ago to a guy down in Veracruz, and he said, oh yes, and what's happening now is they're outfitting barges with big gen sets, and they're taking them alongside islands that have very little space, and they're just selling the power as a service, so floating power plants. And there's a company down in Houston that's working on floating desal. So floating infrastructure is absolutely in our future. And that's why we have continued year after year to talk about it, because it is very important. The last major shipbuilding on the West Coast is San Diego. So this is something that could mean a huge boost for San Diego and those places around the world that are doing shipping and that understand this opportunity and really go after it. So with that, we're going to stop and take questions. Maybe I can ask somebody. Bill, would you be willing to take the switch there? So, any questions for us up here?
Sorry, I wasn't around, but I shouldn't have missed this, really. Since I got the program earlier, I was planning to be in anyway. The floating structures. I don't know if you have addressed that or answered that. Can we get a floating structure nowadays, with the cost, with the technology we have, that can be competitive in terms of course, cost? If I want to have a land-based fish farm and a sea-based fish farm, and farm including all the logistics, it's not just the cages, is it using today's technology, is it competitive? I'm talking large scale. So one of the pictures on the banner of the conference is showing a floating structure. I don't know it's belong or who's that. I don't know. Are you aware of that? It's something like that, a large scale, offshore. When you say offshore, it's mean 20, 30, 40 kilometers away from the shoreline. Viable today for the fishery industry, for the aquaculture industry? Thank you.
I believe very much so, and I would say 2 miles, or rather than 20 meters, okay? You can put it any way you want because it can withstand any normal sea state without, you might as well be on the ground, it's so stable. And the beauty of it is that the real estate, essentially, that you're creating, instead of having people walking around in scuba gear or hanging over the side of a net, you can drive a truck around your nets, okay? And put your feed in with a conveyor belt and take the waste out similarly. This is industrial scale fish farming. And like I say, it'll last forever.
In the presentation of, if you will have a look, but of the port of Guyane, it is foreseen to grow the juvenile inside the structure and have the cage around, so you can pick up the cage and take the fish directly on the ship and directly to the country where it will be exported. So yes, it has been completely studied, and you have all the figures inside the presentation.
I think often what they're talking about is multi-use facilities. So it could be transshipment of cargo, yes, as well as, I don't think that what we're talking about is a dedicated aquaculture only facility. That might make sense as well, but I think many of the ones that were being discussed here are multi-use facilities. I know that Lawrence Livermore started out looking at just a harbor, but then they went to talk with Don Kent at Hubs, and they started looking at wind energy. There's lots of uses, and I know that Neil, for example, the Columbia River can be quite violent up in the Pacific Northwest, and Neil has a different design to dampen that down, which would allow the Columbia River to be more usable, and also has windmills on the outside, so it uses the energy and yet allows the waterways to be better used. So again, there's a dual use, but often we're talking triple, quadruple kinds of use applications. Another question? So I'll ask a question then. So you all are working on a project right now of floating infrastructure. How much does that cost? And is that a stepping stone to something else? And Stefan, what's the Guyana, when is that supposed to really be realized? So Joaquin, why don't you start?
Yeah, in the project that we are working on now, the cost of the main infrastructure is about 10 million euros, and around that, of course, then there is additional cost. The cables, it costs another 3.5 million, and then the satellite infrastructures for wave and wind, they have also additional costs. But what we are trying is just to learn more about working on concrete, because they have a much more longer time life, and also we are learning by doing, sometimes in a very hard way, about the permits, about the consenting, about the social issues, about the logistics, about the operations. And I think that, as has been said before, you can make a calculation of that, but really when you do the implementation and you go to the sea and you see the real problems, is when you have a real sense of what is going on. And also I think that at the end of the day, if you like to involve the investors, you have to show them a pilot phases in where you can show them, okay, this this is the real problems. This is how I do. This is the methodology. This is the certification. and
So
on.
is yours going to be anchored, or is it going to be free float, not free floating, but
The infrastructure that we are building
boosters and-
is make
Thrusters.
with clusters, so we can float it and we can deposit in by gravity in one place. Will be serve as a central hub, deposit on a seabed of 3 meters, but could be removed whenever it will be necessary, just injecting air and moving the water inside, from
Okay.
inside.
Stefan, what's the timetable for that Guyana project? And is that 2 years away, 8 years away, 15 years away?
It will be built before, I believe, 8 years.
Within 8 years.
Way.
And this is
Because there is also a project for employment in Guyana, so it's 3,000 jobs to build this structure. So it's a great project. So this is a problem of investment of the state inside the region, but it will be done anyway. It's sure. And there are also other projects of floating platform that is doing also DCNS for the energy production. So there is a thermal energy production. So you use the water and I don't know how to explain that, but this is a thermodynamic production of energy. You take the energy from the sea. So this is something that you can easily build if this is a floating platform on all the island where there is a good gradient of temperature of the water. That's really perfect to produce energy.
OTEC, basically.
Yeah. Yes, that's it.
Ocean thermal energy conversion.
So it's also in the zone of Guyana, Caraïbes, Guadeloupe, and Tahiti that there will be this project in the next future, 2-3 years at maximum.
So Neil, I was in Hamburg and met Dr. Gordon Dalton, who showed the Maribe program, and there was Float Inc. as one of the companies. So what do you think the timetable is for the Irish project? What comes? Is it a year project? Is it a 5-year project?
The trouble is that there are any number of projects in Ireland right now, and who knows?
Okay, who knows? That's a good answer. Any questions from the floor? So if there are no more questions from, yes, Kim. Could somebody bring her the, hold on. Thank you.
Yes, I was just going to ask, in light of the discussions yesterday, whether there is any public questions about the use of these floating docks, and whether there's been public consultations or problems with stakeholders in their development. Because none of the speakers really touched on that at all.
Let me start that, and then we'll let each of us, opine. These are typically, we're talking about 20, 30 miles offshore, Kim. They're out of view. Therefore, most people don't have no idea they exist. Yes. They'll be picked to be put in spots where the depth is maybe 200 feet. And so what will happen is environmental groups who fight, for example, the Savannah deepening. It's been over 12 years to get permission to go down to 52 feet or whatever it is they've been trying to get. Environmentalists have fought it and fought it and fought it. Well, if you had something 20 miles offshore, you wouldn't see it. People wouldn't be worried about the view, so you could then put in the latest cranes. It takes the homeland security risk offshore. So there's no, visible risk, and it's not close enough like it's Block Island where you see it or hear it or anything like this. The whole idea is you put it, those that I'm aware of, further offshore. So it does a series of things. As a result of that, I've talked about it with Ocean Conservancy, Nature Conservancy, and other people, and they've all said, it sounds great, because they see it as a net win from not having to do detrimental things in the United States. In fact, we were talking with somebody, I can't remember now, they asked us if this would be useful in Alaska, because the concern is that we have no ports up on the north side of Alaska, and the Russians have 10, I think, now. And so there's a huge concern about dredging through the permafrost, and it's apparently very shallow up there. And so it'd be doing incredible violence to nature, which is hard to resuscitate itself. And so here you could build something in a Seattle port and basically float it up there. And I know that Neil has got some examples of some things that have been used, and there was one that was out for 30 years, I think, up in the Arctic, withstood all the ice. And then the Russians bought it and used it for an oil rig as well. So this is an industry, or it's a technology that I think is well vetted, and you can put it out there and actually solve a lot of our problems. But when I was asked to talk with somebody from the U.S. Army Corps of Engineers, because they've been looking at different places on land, and I talked to this guy, I said, you know, we've never thought about a floating harbor. And I went, whoa. You know, I went to MARAD, and the guy that I was talking about, the Maritime Administration, part of the Department of Transportation, person said I was the second person that had ever been there to talk about floating harbors. So I said, who was the first? This guy, Hank Glauser. And we had a non-disclosure agreement with Hank for a couple of years, which we'd been released from. So there aren't many people talking about this. And the Europeans and the Chinese are quite far ahead of the United States. But I think net, there's no question that this should be very acceptable to the NGO community, and we're falling behind. The cost of our containers is going to go up compared to everybody else. So we're going to lose out economically as well.
Can I add a bit to that? There's a couple of advantages that come to mind. One is that this business of transferring the cargoes from transoceanic to coastwise shipping takes an immense number of trucks off the road. And it also puts a hell of a lot of grounded sailors back to work in the coastwise traffic. So it has a double benefit in that regard.
If you want to get into that, there are lists of advantages, and people that have looked at this, I would say dispassionately, have found that economically it's at worst a push and potentially better than that, and the funding exists to do this, and it would be very net positive, both environmentally, socially, economically for the United States. So we have run out of our time, and I will tell Donnie and Ron that the clock up here has not been working. Every once in a while it gives us a little time, like it's exciting us, and then it goes away for 25 seconds and comes back on. So if you could reset, that'd be great. If we could get our last panel coming up. Thank you very much to this panel.
Thank you.